Question number 25, the question from progressive wave, and you could see a progressive wave of this nature is there, and that is represented by this equation. And this thing that you are seeing here is the snapshot at t equals to 0. So for this equation, this is the snapshot at t equals to 0, then what would be the value of phi, the initial phase? One thing is there, if I just put t equals to 0, then the equation should be a sine kx plus phi. So that's the equation at t equals to 0. And if this has to satisfy this, quite obviously the value of phi has to be equals to pi, because this is a minus a sine kx graph. So you get the value of phase is equal to pi. Therefore, option number 1 is the correct option for this question. Let's move for the next. 26th question. A man of mass 50 kg, his son of mass 20 kg are standing on a frictionless surface facing each other. The man pushed his son so that so that really means the son, starts moving at a speed of 0.70 meter per second with respect to the man. The man should not have done so. He pushed his son on the frictionless surface. Still, for the sake of numerical, let's see. The speed of the man with respect to the surface, you need to calculate. Okay, now just by conservation of momentum, if I write, I can do one thing. 50 V1 would be equals to 20 V2. That's the first thing, momentum conservation. And together, see, it says that the man pushed his son so that he starts moving at a speed of 0.7 meter per second with respect to the man. That means you get V2 plus V1 would be equals to 0.7. All right, two equation, two unknown. You need to calculate the speed of the man. That is the value of V1. You do it, you'll get option number 1 as the correct option. Let's move to question number 27. Calorimetry. The question has been put, and that's what I've been saying. We need to focus on those areas of the first year syllabus which is post-gravitation. That's quite important. You see the occurrence of the question that really gives you an insight. It is such that m1 gram of ice at minus 10, the specific heat is given, is added to m2 gram of water at 50 degrees centigrade. And during that heat exchange, finally no ice is melted. That means all the ice has melted. And the ultimate mixture is water at 0 degrees centigrade. Based on this data, we need to calculate the latent heat of ice. So let's use the principle of calorimetry, heat gained equals to heat lost. So the gaining part is ice, that will be M1, C is 0.5, the change in temperature is 10. This will bring ice at minus 10 to ice at 0. And this ice at 0 has to go to water at 0, M1L. That side, water at 50 degree has to come to water at 0. So M2 and C of water, that's a known fact, 1, and delta theta is 50. Okay, this is the given equation, and just to calculate the value of L from this, it's almost a verbal done. That will lead you to option number 1 as the correct option. Let's move to question number 28.